In today's lesson, we are going to go over how to rewrite scientific notation so it has the same exponent. Welcome back to my channel, Numerics with Nadia, and let's get into our learning objectives for today. First off, we want to be able to understand why exponents must match for addition and subtraction in scientific notation. Then we'll learn how to adjust scientific notation to have the same exponent. And last but not least, we'll learn how to solve problems by rewriting numbers in equivalent forms. If you guys haven't watched my last video on scientific notation, how to add, subtract, multiply, and divide them, please go ahead and watch that video before this one. I'll go ahead and tag it right here and then come back to this lesson so we can understand why we need the same exponent to be able to add and subtract scientific notation. So now that we've gone over our lesson overview, let's go over why we need the same exponent to add and subtract scientific notation. So the exponents must be the same because scientific notation represents values as powers of 10. And if the exponents are different, the place values won't align. So we won't be able to add and subtract them. The way I will illustrate this to you guys is through an example. So let's say that we were adding 3,542. We wouldn't just add the 3 and the 4 and the 5 and the 2, right? What we have to do is we have to align the place values. And when we do that, I like to do it vertically. When we align the place values, then we add. That is when we would get the correct answer. It's essentially the exact same thing for scientific notation. Numbers with different exponents represent values at different magnitudes. So we have to rewrite them with the same power of 10 before we can do any type of adding or subtracting. Now let's get into the steps to rewrite scientific notation with the same exponent. So first off, in our example, we have 5.2 times 10 to the 4 and 3.1 times 10 to the 3. Now we want to identify the numbers and their exponents, and we're going to decide which exponent to use. Here we're going to choose the larger exponent, which in this case is 10 to the 4th. Now we're going to adjust the coefficient of the number with the smaller exponent. So we have 3.1 times 10 cubed. What we're going to do is we're going to shift the decimal one place left, and then increase the exponent by 1. And when we do that, we would rewrite our numbers, and now they both have the same exponent. We have 5.2 times 10 to the 4th. That one stayed the same. And we rewrote 3.1 times 10 cubed as 0.31 times 10 to the 4th. And now that both numbers have the same exponent, they are ready for either addition or subtraction. So now that we've gone over the steps, let's get into our practice problems for today. Our first one says to rewrite so both numbers have the same exponent. Like we did in our steps, we're going to look at which number has the higher exponent. Here it is 4.5 times 10 to the 6. So what we're going to do is we're going to rewrite the 2.1 times 10 to the 5 using the strategy that we went over in our steps. So if we move the decimal one place to the left, that means that we can increase our power by 1. So 2.1 times 10 to the 5th is the same as 0.21 times 10 to the 6th. And when we rewrite them, now they both have the same exponent. For number 2, we're going to do the same steps. We're going to rewrite the two numbers, but also we're going to add them. So looking here, we have 8.3 times 10 to the 8th plus 6.2 times 10 to the 6th. We're going to convert that 10 to the 6th to 10 to the 8th. In order to do this, we have to move our decimal now 2 places to the left to be able to increase our exponent by 2. And when we do that, we'll get 0.062 times 10 to the 8th. Now when we rewrite them, we should have the same exponent. We'll have 8.3 times 10 to the 8th and 0.062 times 10 to the 8th. Now when we go to add them, we're going to do the same steps we covered in our video from last time. So again, if you haven't watched that, I'll go ahead and tag it right here for you guys. What we're going to do is we're just going to add the coefficients and the powers will be along for the ride. Our coefficients here are the 8.3 and the 0.062. When we add them together, we get 8.362 and the exponent stays the same. So our answer would be 8.362 times 10 to the 8th. Now we'll get into our third and final practice question. For this one, it says to rewrite before subtracting. Looking at our two exponents, 10 to the 9th is the greater exponent. So what we're going to do is we're going to rewrite that 3.4 times 10 to the 7th Same as in number 2, we have to move the decimal place 2 places over in order to increase our exponent by 2. So when we rewrite 3.4 times 10 to the 7th, it will be 0.034 times 10 to the 9th. And now that matches our exponent with the 5.7 times 10 to the 9th. So we can go through here and subtract them. The steps are the exact same if you are adding or subtracting. So here we will write them out. 5.7 times 10 to the 9th minus 0.034 times 10 to the 9th. We will just subtract our coefficients. 5.7 minus 0.034 gives us 5.666. So our answer would be 5.666 times 10 to the 9th. And that wraps up our video for today. I hope you guys enjoyed this lesson on rewriting scientific notation. Please feel free to like the video if you enjoyed it. Comment any questions or any other video topics you would like to see down below. Subscribe if you haven't already. Share this video with a friend, and I will see you guys next time.